oceans apart and it's
Let's take a look at the economics of harnessing tidal energy. To do this, we have to first determine what actually generates these tides on Earth. So these tides on Earth are formed by the gravitational forces exerted on the waters of the Earth by the moon and the sun. Now, even though this moon is substantially smaller than the sun, because it is so close to Earth, it plays a far more dominant role in the strength and the height of the tides than the sun does. So there are two main factors in determining how strong the tide is. First of all is the alignment of the sun, the moon, and the Earth, and also another factor that determines the strength of the tides is how close the moon is in its elliptical orbit to the Earth. So when the moon is the closest, it is called perigee, and when they are all aligned, these are called spring tides. So when these two factors are combined, it causes spring perigean tides, which are the strongest and the tallest. Conversely, when the moon and the sun are acting at right angles to each other and the moon is at its farthest point in its elliptical orbit, these are called apogean neap tides. This is when the tides are the weakest. Now let's take a look at what infrastructure needs to be in place in order to effectively harness this tidal energy. So let's look at the example of the Bay of Fundy. What makes this location so extremely cost-effective when it comes to harnessing tidal energy? Well, the main characteristics of the Bay of Fundy include a large height differentiation when it comes to high and low tides. They've effectively installed a tidal barrage in order to harness this tidal energy. So how tidal barrages works are the sluice gates open in order to let the water into the basin, and then the water is stored there until it reaches high tide. Afterwards, the sluice gates open again and the water rushes out, turning the turbines, therefore generating electricity. However, this can have large ecological impacts on the aquatic and the shoreline ecosystems. So another way to harness this tidal energy is by utilizing tidal current turbines. These are essentially wind turbines situated underwater, and how it works is that the tide will flow and then therefore this will turn the blades, generating electricity. Now these have less ecological impacts than tidal barrages because the blades are specifically designed to spin slower so as not to affect marine life. Also, seawater is 832 times denser than air, and therefore, even though the blades are much shorter than those of a wind turbine, they can generate just as much energy. Now, let's look at some of the costs that go into tidal barrages and tidal current turbines. La Rance in France, for example, costs approximately $66 million to build, whereas tidal current turbines are approximately $4 million each. Even though there is a large initial cost associated with building these tidal barrages, it is important to note that once they are in operation, there are minimal costs to generating electricity. The electricity generated can go to benefit as many as 300,000 inhabitants of the nearest town, as is shown in the example of La Rance in France, which is the oldest operating tidal barrage that has ever been built, and it was built in 1967. Additionally, the consumers will benefit because they actually see their electricity bills go down after utilizing tidal energy sources. Not only is tidal energy cost-effective, efficient, green, and renewable, it could hold the key to the future of energy generation. This could replace our dependence on fossil fuels, and for this reason, we believe that we should go with the flow and go tidal.
We all came out from